Welcome to this explainer. Okay, today we're diving into a literal paradigm shift in how we interact with our coastlines. We are looking at Project Lit A, the coastal intelligence platform. If you're fascinated by that wild intersection of artificial intelligence, edge computing, and real-world life-saving infrastructure, well, you are absolutely in the right place. We're talking about taking coastal safety from a passive sit-and-watch system into a highly predictive, active, multi-tiered marine network. Let's get right into it. Just let this quote sink in for a second. For generations, lighthouses warned us, now they act without us. Historically, coastal infrastructure, it's been entirely passive. Think about a traditional lighthouse, right? It just sits there, shines a light, and basically hopes ship's captain sees it and makes the right call. It is a totally one-way street. But Project Lit A flips that on its head with autonomous coastal intelligence. We're moving from infrastructure that just stands around and warns to systems that actively respond and intervene, entirely without us needing to hold their hand. Section 1. The fragmented ocean problem. So there's this massive disconnect between our idealized vision of an ocean rescue, a swift, perfectly coordinated response, and the actual reality on the ground. Right now, coastal emergencies, environmental monitoring, maritime ops, they all rely on hardware from completely different manufacturers. They use different communication protocols, trying to manually juggle all these different brands and their proprietary controllers during an escalating chaotic crisis. It's honestly a nightmare. It is practically impossible. And that brings us to the biggest bottleneck of all, us, the human delay. In an emergency, a single human signal can change absolutely everything. But waiting for a person to interpret all that disjointed data from disconnected systems and then manually trigger a response, that costs precious time. And out in the ocean, a delay in human decision-making isn't just a minor inconvenience. It creates a fatal gap. It is literally the difference between a successful rescue and a tragedy. Our current setup introduces friction right where we need speed the most. Which brings us to Section 2. Enter Project Lit A. To solve this massive fragmentation problem, Project Lit A just completely eliminates vendor lock-in. They do this through what they call a unified autonomous rescue integration architecture. I know, that sounds like a mouthful, so let's break it down. Basically, think of it as the ultimate universal device adapter. It's an AI-powered integration management system running on a cloud-native platform, specifically Google Kubernetes Engine. This architecture acts like a master conductor. It grabs all those stubborn, proprietary pieces of hardware that usually refuse to talk to each other, and it translates their data into standardized, unified operational capabilities. It's a total game changer. Section 3. Unifying rescue technology. To secure every single layer of the ocean, specifically focusing on the atmospheric and surface layers, Project Lit A rolls out a massive, highly diverse hardware fleet. And we really see this tech pushed to the absolute limit during storm season. I mean, it is a true visual spectacle seeing this autonomous platform battling massive coastal storms. Up in the sky, you've got JTT Spider UAVs keeping watch. These things are rigorously tested for stability in high winds, taking on the incredibly high-stakes challenge of 30-knot gusts without breaking a sweat. Down on the surface, we're talking USA smart buoys, autonomous rescue robots like the R2 Procrafts, Xenodrome spotters, and Ouster lidar arrays mapping everything in high resolution. In the past, getting a JTT drone to coordinate with a USAF buoy in the middle of a raging storm would be a complete logistical nightmare, but Project Lit A gets them all operating seamlessly as one single entity. So how do all these totally different devices actually sync up during such extreme conditions? Well, they're connected through a secure API federation. But this isn't just some theoretical concept. We're talking about serious telemetry under pressure. When that JTT Spider drone gets slammed by a massive 30-knot storm gust, corrective algorithms instantly trigger over a high-throughput edge data network. All that data streams straight into their Triton ML inference pool, which is basically the central brain of the platform. This brain actively engages across 3 distinct compositional layers of the ocean. It takes what used to be a random assortment of rescue robots, drones, cameras, and edge computing gateways and fuses them into a single, geolocation-aware autonomous fleet that senses and responds flawlessly, in real time. Section 4. Beyond emergency response. Now, it's important to note, this intelligence network isn't just sitting around dormant waiting for someone to hit an SOS button. Way beyond emergency response, the AI is continuously observing the marine ecosystem. It acts like an ever-watchful guardian for the environment. The AI actively identifies wildlife activity. It monitors water quality and tracks changing environmental conditions 24/7. Because it's leveraging the exact same sensors and LiDAR arrays used for storm tracking and coastal emergencies, Project Lit A provides this unprecedented continuous stream of data about the overall health and activity of our coastal waters. It's really doing double duty. Section 5. The Mobile Lighthouse Future. To really accelerate this impact, the team is validating the whole ecosystem through a modular pilot program. They are completely redefining the concept of a waterfront tower by building these modular, mobile MVP lighthouses. These are definitely not your grandpa's brick-and-mortar monoliths. They're smart, structurally viable, and incredibly adaptable units. And the coolest part? They are designed to be rear-wheel attachable. That means you can literally hitch up the entire intelligence hub and transport it to wherever the coastal risk happens to be highest at any given moment. Let's quickly walk through how these deploy because the engineering here is absolutely brilliant. Step 1. The base and wheels are rolled into position using what's described as ocean-resilient buoyancy to make sure they stay completely stable right at the water's edge. Step 2 is where it gets super sci-fi. The structure uses a pneumatic assembly, so it literally builds itself up from a structured retractable containment unit. It just pops right up. And finally, step 3, once it's fully assembled, the tower securely houses all the necessary edge AI gateways. Those are the local servers processing data instantly without needing a slow connection to a distant cloud, plus all the components needed to power the unified fleet. It's an instant mobile command center. Which brings us to our final thought for today. At the beginning, we talked about that fatal gap, the human delay between a crisis happening and a response actually launching. Project Lit fundamentally removes that delay. It connects sensing and response in real time to build a fast, flawless future. So I want to leave you with this question to ponder. If our infrastructure can now observe, process, and act entirely on its own, what if the rescue was instantaneous? Thanks for joining me for this explainer. I really hope it helped illuminate this massive shift from passive warnings to active, autonomous coastal intelligence. See you next time.